All right, welcome. We're about to go on a little journey to break down the fundamental rules of, well, everything around us. It's all about finding the simple, elegant ideas hidden inside our incredibly complex world.
And that quote really hits the nail on the head. Chemistry isn't just something that happens with beakers in a lab. We are living and breathing it. The air, the water we drink, the phone you're holding in your hand, it's all chemistry.
So that brings us to the big question for today, right? If everything is just chemistry, then what is all this stuff actually made of? To figure that out, we're going to have to zoom in, like way, way in.
Okay, let's get into it. Our first stop on this whole journey is just understanding the big picture, the chemical world that you and I can see and touch every single day.
It all starts with one super simple concept: matter. That's the technical term for, well, stuff. Everything. Anything that has mass and takes up space. From a huge mountain to the ice cream in your freezer, it's all just matter.
Now, this matter comes in a few different flavors, or states. Most of us know the first three by heart, right? You've got solids, which hold their shape, liquids, which take the shape of whatever you put them in, and gases, which just expand to fill up any container. But there's a fourth one: plasma. Think of it as a super hot electrically charged gas. It's what stars and lightning are made of.
So we've got a handle on what matter is and the different forms it can take. Now let's peel back that first layer and see how scientists actually classify all this stuff.
At a really high level, you can sort all matter into two big buckets. In one bucket, you have pure substances. Think of pure water or a bar of solid gold. It's made of only one type of particle. In the other bucket, you have mixtures. That's like the air we're breathing, a jumble of different gases, or seawater, which has salt and all sorts of other things mixed in.
Okay, let's zoom in on that pure substances bucket for a sec. It actually has two types inside of it: elements and compounds. Elements are the absolute most basic building blocks. You can't break them down any further. Things like oxygen or gold. But when those elements react and chemically lock together, they form compounds, like water, H2O. And get this, there are only about 116 known elements, but they combine to create over 29 million known compounds. It's incredible.
Okay, you see where this is going, right? We've gone from matter to pure substances to elements. Now it's time to zoom in one final time to the fundamental unit of an element, the atom. And here it is, the atom. This is the bedrock. It is the absolute smallest piece of an element you can have that still behaves like that element. Everything comes back to this.
So what is an atom made of? You'd think it would be crazy complicated, but it's shockingly simple. It's just three core particles. You've got the positive protons and the neutral neutrons hanging out in the middle, in the nucleus. And then you have these tiny negative electrons buzzing around the outside. That's it. Every single thing in the universe is made from some combination of just these three things. And just to give you a sense of scale here, this number, 37 picometers, is the radius of one single hydrogen atom. That's 37 times trillionths of a meter. We're talking about a scale that is just mind-bendingly small.
Which, hold on, that leads to a really fantastic question. If a gold atom, an iron atom, an oxygen atom, if they're all made from the exact same three particles, protons, neutrons, and electrons, then what on earth makes them different? Why is gold, gold?
Well, the answer is so simple it's almost beautiful, and it's all perfectly organized in what I like to call the ultimate cheat sheet for the universe. That's right, the entire identity of every element in existence, the one thing that separates gold from iron, it all comes down to one simple number.
And this is it. It's called the atomic number, and it's nothing more than the number of protons in an atom's nucleus. That's the secret sauce. An atom with one proton is always hydrogen. An atom with 79 protons is always gold. Period. It's the unique fingerprint, the unchangeable ID card for every single element.
And here is where we see that rule in all its glory, the periodic table. This isn't just some scary chart from high school science class. It's the cheat sheet. It's a map that organizes every known element by that one magic number. And in doing so, it helps us predict exactly how they're all going to behave.
Okay, so let's recap. We know what stuff is made of: atoms. We know what makes atoms different from each other: their proton count. So the last piece of the puzzle is, how do these atoms actually stick together to form the millions of compounds we see all around us?
Well, the biggest motivation for atoms to get together is something called the octet rule.
Basically, you can think of atoms as being happiest or most stable when they have exactly 8 electrons in their outermost layer, and they will do almost anything to get to that magic number 8.
And to get to that stable state, atoms have two main strategies. The first is what we call an ionic bond, which is basically a give-and-take situation. One atom literally gives an electron away to another one. The second strategy is a covalent bond, where atoms decide that sharing is caring, and they share electrons between them.
Let's look at a classic example of that give and take. Just plain old table salt, NaCl. Sodium has one extra electron in its outer shell that it's just dying to get rid of. Meanwhile, chlorine has 7, and it desperately wants just one more to make 8. So, boom, sodium gives its electron to chlorine. Now they're both stable, but they have opposite electrical charges, which makes them stick together like tiny little magnets.
So what about that sharing strategy? Well, let's take 2 fluorine atoms. Each one starts with 7 electrons, and they each want one more. But neither one is strong enough to just steal an electron from the other. So what do? They compromise. They each put one electron into the middle, and they share that pair. Now, by sharing, both atoms feel like they have a full, stable set of 8.
So, we've gone from the entire material world all the way down to 3 simple particles and a few basic rules, and then zoomed back out. And it kind of leaves you with this one final huge question, doesn't it? If every single substance, from a distant star to a cell inside your own body, is just a different arrangement of these same basic particles, what truly separates the things that are alive from the things that are not? Definitely something to think about.